Hey, welcome back. Today we are just going to quickly go through the practice section for 7.4 in your assignment booklets. That's the part about the parallel and perpendicular lines and how their slopes relate. So we'll get started. So the first question is just going over whether or not you know how to figure out whether lines are parallel, perpendicular, or neither. And remember, parallel lines have the same slope, whereas perpendicular lines have slopes that are negative reciprocals. Okay? Now, the thing that's important to actually solving problems about perpendicular lines are that when you multiply the slopes, they always give a product of -1, with the exception of those difficult to deal with lines, horizontal and vertical. Okay? So horizontal and vertical lines will not multiply to give you a slope of -1, but they never cooperate anyways. Okay? So in order to decide whether a pair of lines is parallel, perpendicular, or neither, what you have to do is find the slopes. Okay? You can't say anything about them if you don't know their slopes. So that's the first thing we're going to do. They've been kind to us. This first equation is in slope-intercept form. So remember what that means is we don't have to do any calculating, rearranging, or anything. We just have to look and see what is the coefficient of x. In other words, what number is attached to x. So, bang, we know that the slope is 9. With this one, they're not being quite as nice. They've given us this line in general form, so we're going to have to rearrange. Okay, we're going to have to isolate y. And because I'm lazy, I'm going to isolate y by adding 2y to both sides. Okay? That will give us cancellation on this side, and 18x plus 13 equals 2y on this side. And then to isolate y, remember it doesn't matter if you isolate it on the right side or on the left side. Typically we always do it on the left side, but it makes no difference. Okay? So this allows me to kind of do it in fewer steps. So now we have to get rid of the 2. Remember, when we're dividing or multiplying, we're doing it by every term in the equation. 2 divided by 2 gives us 1y. 13 divided by 2 can't be simplified. That's okay, we don't care about that. 18 divided by 2 gives us 9x, which is what we do care about. The coefficient of x, again, gives us our slope, because now it's in slope-intercept form. And that gives us a slope of 9. Well, slope of 9, these guys are parallel, okay? Because they have the same slopes. That means they have the same steepness, same direction. Moving right along. For B, they've been very nice to us because they've given us one line in point slope form, which remember is another one of those forms of the equation where all you have to do is look. Okay? So, the number outside the expression containing x is your slope, so our slope here is 3/2. This one, although it looks a little odd, if I write it like this, all that means is this is a line in slope-intercept form that has a y-intercept of 0, okay? All you have to check is y isolated? Is everything else on the other side? And is there a term containing x on the other side? If those boxes are checked, it's in slope-intercept form. And so what that tells us is slope equals 2/3. Well, it kind of looks similar, but they're not exactly the same, so they're not parallel. Remember, if they're perpendicular, then by multiplying the slopes together, we should get an answer of -1. So let's see if they're perpendicular. Let's multiply the slopes. So we say, are they perpendicular? If we take the slope of the first one and we multiply it by the slope of the second one, that gives us 6/6, or +1. Okay, remember, in order for them to be perpendicular, the product has to be -1. So these two lines are neither parallel nor perpendicular. Okay, just two lines. So, C. Now again, they've been very kind to us, and this might be a time to mention to you that this particular section of the module is probably a little easier than it should be, okay? Make sure that in preparation for your test, remember your test is on May the 26th at 1 o'clock. In preparation for your test, I have downloaded or uploaded to Google Classroom a chapter review that I normally use when I'm teaching this course to you guys in a real classroom in non-COVID times. Make sure you work through that review. I've also included the key with all the solutions, so that will give you a better indication of the degree of difficulty of your test, okay? Anyways, these are both in slope-intercept form, which means we can just very quickly say the slope of this guy is 2.5, the slope of this guy is -0.4, okay? So, first of all, obviously not parallel, right? They don't have the same slope. Perpendicular, not as easy to tell just by looking, but remember, we have this test we can apply. If we multiply the slopes, so 2.5 times -0.4, get out Mr. Calculator, and you'll find that when you multiply them together, that gives you a product of -1. And that means these guys are perpendicular. Okay? So, quick test. Now, we did some of these in the actual lesson. If you haven't looked at the lesson, it's a two-parter for 7.4, and it's on YouTube, just like this one will eventually be. Take a look at those. So it says line A passes through the points 1, -1, and 5, 3. So let's just very quickly sketch this so that we kind of have something to look at, okay? So line A passes through the point 1, -1, which is right about here, and 5, 3, which is right about here. Okay, so there's line A. It says line B passes through the points 7, -5. So again, that one was 5, so we'll say this one is 7, and -5 is down here somewhere. Okay? Determine a value of R such that the two lines are parallel. So, I'm just going to extend this. If they're parallel, you know that line B is going to look something like this. Okay, so there's line B. So and it says 1r, so that means 1 across. So that means this is about where it's going to go. 1r. This doesn't solve the problem, but it at least gives you something to look at. Okay? So you know your answer is going to be, significantly negative. Or your value for r will be significantly negative, the y-coordinate. Determine a value of r such that the two lines are parallel. So, this is your clue. When they say the two lines are parallel, that means they have the same slope. And given that you have 2 points for line A, your first step is find slope of line A. That we can do. We have a slope formula, we have 2 points, so again slope equals y2 minus y1 over x2 minus x1. Plug in your values, y2 minus y1 becomes 3 minus negative 1, x2 minus x1 becomes 5 minus negative 1. And that gives us a value of, remember, 3 minus negative 1 is like saying 3 plus 1. That gives us 4. Similarly, 5 minus negative 1 gives us 6. And in simplest form, that's 2 over 3. Okay? So we know the slope of our line A is 2 over 3. We know that our line B is parallel, so we can say, therefore, slope of line B also equals 2 over 3, because they're parallel. Okay? Okay, so we found the slope of line A. Now, step 2, use slope of line A and slope formula. And I'll just put in brackets, you can also use the slope point formula because remember, one is just a rearrangement of the other. I like to use the slope formula because it tends to result in fewer dealings with fractions. Okay? So, use the slope of A and the slope formula to find r. So we'll just leave our slope formula right here. So in dealing with line B, remember we're dealing with line B now, we know the slope of line B. Remember it's the same as the slope of line A, it's 2 over 3. Our y2 is negative 5. Our y1 is r, right? That's our variable. We don't know what that is. I'm just going to put these in brackets. And then our x2 minus x1 becomes 7 minus 1. Okay? Let's simplify. 2 over 3 equals negative 5 minus r all over 6. Now what have we got here? I'll tell you what we have. We have a proportion, right? Where you have a fraction on one side, a fraction on the other side, and remember, the easiest way to simplify a proportion is by cross multiplying. So let's do that. So we're going to go 2 times 6 is 12. 3 times negative 5 minus r, I'm just going to write that as 3 times negative 5 minus r. Okay? So we've done our cross multiplying, and we've run out of space, so I'm going to move over here. So we need to simplify the right side before we can start rearranging the equation. So we're going to distribute this 3 over everything inside, and that will give us 12 equals 3 times negative 5 is negative 15. 3 times minus r is minus 3r. See how things are kind of simplifying out a bit? Isolate r. Do the adding and subtracting stuff first. So we add 15 to both sides, cancels here, gives us 27 here, equals negative 3r. Last step, get rid of the 3. Since we're dividing it, taking it out of the 3r, we have to divide both sides. Negative 3 divided by negative 3 leaves us with 1r. Yay, it's isolated. 27 divided by 3 is negative 9. And since we have our handy little sketch over here, we can say, does that make sense? Well, look, our y-coordinate is way down here. That makes sense, right? R of negative 9 is way down into the negative on the y-axis. Perpendicular. Okay, so I'm just going to very quickly remember our slope of A was 2 over 3. Now, because these lines are perpendicular, just let me write my coordinates out for line B. It was 7, negative 5, and 1r. Okay. So 7 and negative 5, 1 and r, because we're going to need to use those. Okay, so to find a value for r, given that they have to be perpendicular, remembering that if they're perpendicular, that means we are no longer concerning ourselves with a parallel line B. What we want now is a perpendicular line B. Okay? So that means we still have a value of 1 for our x. We're looking for a value up here somewhere, right? 1 across and r. So this time, and you can just, very quickly eyeball it, we should get a value for r somewhere around 5. Okay? But okay, so we can still leave all of these instructions up here because we're still doing the same thing. The only difference is, instead of using the slope of A, we're going to use the negative reciprocal of the slope of A. So in other words, our slope for B will be flip it and change the sign. Our slope for B will be negative 3 over 2. Okay? Because remember, it's perpendicular now, it's not parallel. Otherwise, exactly the same. So let's plug in our slope for B, negative 3 over 2. Our y2 is negative 5 minus y1. Our x2 is 7 minus 1. And remember, that simplifies to 6, so we get negative 3 over 2 equals negative 5 minus r over 6. What did we do next? Of course you remember, we cross-multiplied because this is a proportion. So negative 3 times 6 is negative 18. 2 times minus 5 minus r. We'll bring it back up here so you can actually see it. Remember, we're going to simplify the right side by distributing 2 over everything inside here. That gives us negative 18 equals negative 10, right? 2 times negative 5 minus 2r. And then we isolate the variable. Add 10 to both sides. Always do adding and subtracting first. They cancel. We have negative 8 here. Okay. Equals negative 2r. Get rid of the negative 2 by dividing both sides by negative 2. And that gives us negative 8 divided by negative 2 is 4 equals r. So I guessed 5, it's 4, close enough. Okay? So our value of r in the case of the perpendicular line is 4. Moving right along. Okay. The grid shows two perpendicular lines. Use the information provided on the grid to show that the slopes of the lines have a product of -1. In other words, prove that they're perpendicular. So remember, we said that we'll call, oh, here we go. So this is line A, this is line B, and we know that if we take the slope of A and multiply it by the slope of B, what answer should we get? -1, if they're perpendicular. So, they've been very kind to us. They've given us rise and run, so we don't have to absolutely use the slope formula, because we know that to get from this point to this point, you have to go 1, 2, 3, 4 down, so -4, and then 1, 2, 3 to the right, so +3. Okay? That gives us a slope for A, rise over run, of -4/3. Easy, huh? For B, to get from this point to this point, we have to go 1, 2, 3, 4 to the right. Again, that's positive, and 1, 2, 3 up, also positive because we're going up. That gives us rise over run of 3/4. And -4 times 3 is -12. 3 times 4 is +12. That equals -1. Therefore, we've proven that they're perpendicular. Okay? Tony and James. So, Tony and James both walked home from school as shown in the graph provided. So, let's take a look at this and try to interpret it. So, we have a distance, we have a time. So for Tony, he started at a distance of 0 at a certain time, okay? And it shows that as time progresses, his distance increases. So, Tony is walking from his start point, school, to his end point, which is at home. Now, they haven't told you where home is, right? So, for instance, home could be at this distance or at this distance. These are just lines, okay? So, but they both walked home from school. Tony left at this time. We can arbitrarily assign a value to this of 1. James also walked home, but you can see from his line, he must have left a little bit later, right? Because his time doesn't, his distance doesn't start increasing until later on in time, okay? So, describe the scenario that would lead to this graph. Tony left school at the bell. James stayed for basketball practice. Both of them eventually got home. Both of them started at the same distance of 0, and both of them, as I said, eventually got home. It's just that James left later than Tony. Okay? The two lines on the graph are parallel. Explain what this means in the given context. Well, if they're parallel, that means slopes are the same, right? And further, in the context of this situation, since slope equals rise over run. If we look at the units that are used, they're units of distance, and let's just say meters, over time, minutes. Well, you'll all remember from Unit 2 of Science, the physics unit, the quantity whose units are distance divided by time is speed or velocity, okay? So the fact that the slopes are the same means they walked at, running out of space, at the same speed. Okay? So whatever speed Tony walked at, James walked at the same speed because their slopes are the same. Suppose the two lines were not parallel. Would this guarantee that James and Tony will meet? Explain. The best we can say about this is maybe. Okay? I think it was Tony who left first. Was it Tony? Yes. If Tony walks really slow and James really fast, they might, okay? However, it absolutely is not a guarantee, okay? So if we go back to our graph, if our graph for Tony, let's say it's at this distance home is this far away from school, okay? So if James continues at the speed he's going and Tony walks really, really slow, remember really, really slow would be a very shallow slope, then they will meet, okay? However, if Tony walks really, really fast, remember that will be a steeper slope, then they'll never meet, okay? Their lines will never cross, okay? So it isn't a given that just because their lines have different slopes, they will necessarily meet, okay? Oh, we're done. That was a little bit quicker than the last day. Anyways, I hope this helps you with your assignment booklet for 7.4. Remember, you can always email. Remember to look at some of the other YouTube videos. They will probably help you, I hope. And please feel free to comment if you think there's anything I can do to improve these videos for you. Have a great day.